Okay, let's try the next question here. We got 2 minus cos squared plus 4 sine x. Okay, that could be tricky. But I'm looking at this sine x thing here, and I'm thinking if I could put this in terms of sine, that's why I chose 1 minus sine squared. Then everything will be sine. That's usually a good idea. If you can get it in terms of 1, that's good. Well, 2 minus 1 is just 1. Minus sine squared is plus sine squared, and it's plus 4 sine x. Hey, this is promising, except it didn't factor. Um, if you have a squared plus 4a plus 1, it doesn't factor. Well, if it doesn't factor, what can you do? Or if you don't know how to factor it, it's not working factoring, just get the quadratic formula out. A is 1, B is 4, C is 1. Now, they rarely ever do this, but if it ever happens, use the formula. If you use the formula and it does factor, you're going to get the right answers anyway. So if you get stuck or something's not working, put it in the quadratic formula. Now we've got these two values. Go shift sign of these values. So I went shift sign of 4 minus 4 plus root 12 over 2. I just put those numbers in the quadratic formula. I get negative 15.5 degrees plus k times 360. And then 180 minus makes it 195, comma 5 degrees, it should say there. They're missing a point, 5, comma 5 degrees there. And that is that one done. Let's take a look at how I did this one. Now, I think they start to get pretty tricky. There's more than one way to do them, but sine 2x, you're locked into making that 2 sine x cos x. If you make this cos 2x, you've got three choices. Now, it looks like I'm going to have sine x cos x in the middle. So I'm going to have a thing with cos squared and sine squared, because if it's a trinomial, and the middle is sine x cos x, I must have cos squared and sine squared. So I put this in here. 2 cos squared plus cos, oh yeah, what is it? Cos 2x is cos squared minus sine squared. Well, that gives me 3 cos squared. And there's minus sine squared. There's my 2 sine x. Now, why did I have to change this to a number? Because it's got to be sine squared and sine cos x. It's the only way this thing can work out. So it's minus 2 sine squared minus 2 sine squared here. Okay, 3 cos squared minus 2 cos squared, that's just 1 cos squared. And then what do we have here? Minus 1 minus another 2, it's minus 3 sine squared. Now this is promising. I put cos x, why don't I just do a FOIL kind of thing here? Cos x times cos x is cos squared. Sine x, it has to be times 3, and it's got to be a negative times a positive, plus 3 sine x cos x minus 1 sine x cos x. Hey, this works out. So there we've got it. We let these two things equal 0, and we use that tangent trick. We've got sine x equals cos x. We make cos x minus sine x equals 0. Divide both sides by cos x, you get tan x equals 1. That's one of yours. The other one is 3 sine x equals minus cos x. Divide everything by cos x and by 3. Divide by cos x, you get tan x. Divide by 3. The cos x divided by cos x is 1, but you get a 3 in the bottom. Well, shift tan of minus a third and shift tan of 1, that's 45 degrees. And shift tan of minus a third is minus 18.4 degrees. So this is just experience, knowing it's a trinomial, but the secret of it is this 2 sine x cos x, I can't have a number on the end, because if the outside and the inside are giving me this, these cross products, the outside and the inside, I know it's got to be cos squared x and sine squared x here. So that's why I put everything in terms of changed 1 into sine squared plus cos squared, and I changed a 2 cos 2x into cos squared minus sine squared. That question is pretty challenging, I think.